Hello learners, today we will still continue with the topic angle properties of a circle. So I'm going to solve the question I'd given you, number 5, from secondary mathematics, exercise 19.1, number 5. So I'll read the question. In the figure below, O is the center of the circle. Ln and Pm are diameters. Show that Lm is parallel to Pn. So I'll write the question on the board. The question on the board, I read, in the figure below, O is the center of the circle. Ln and Pm are the diameters. Show that Lm and Plm, show that Lm is parallel to Pn. So to solve that question, there are concepts you must have. Number 1, when they talk of diameters, there are 2 diameters there, Ln and Pm. From the previous concepts, we had seen that a diameter will subtend a right angle in any of the segments. So let us look at the diagram and see some of the angles the diameters will subtend. Because from the question, before you prove it, a parallel line, 2 parallel lines, a perpendicular drawn from a point on one of the line should meet the other line at 90 degrees. So if we are able to identify some of those angles, they'll be able to help us to prove that. So let's see some of the angles formed in that. So let's start with diameter Ln. Diameter Ln. We want to see whether there is any right angle it is subtending. So if I prolong that and got that small chord there, I will already get a right angle there. It is a true proof that angle LMN is a right angle because it is subtended by which chord? Ln, which is the diameter. Therefore, angle LMN is equals to 90 degrees, which is a right angle. We get, let's find other angles also. Let's consider also chord diameter PM. Diameter PM. If we prolong this chord L to P, we'll find that diameter PO, diameter PM will subtend angle MLP, which will also be a right angle. So it goes without saying that angle MLP is equal to 90 degrees. We are not done yet. There are 2 more right angles we'll get. There are 2 more right angles we'll get. So we've got angle LMN, LMN, and we've got angle MLP. We can also get angle LPN, which is a right angle because it is subtended by chord LN. A diameter subtends a right angle on any point on the circumference. So it goes without saying that angle LPN, angle LPN is equal to 90 degrees. Reason it is subtended by the diameter. We go to the last 4th angle, which is angle MNP. Angle MNP. It is subtended by diameter PM. You can easily see this is the diameter. It is subtending this angle in that segment. So it goes without saying that angle MNP is how many degrees? 90 degrees. We've got all those concepts from the diameters subtending angles in any of the segment. The angles will be 90 degrees. So we go back to the question where we are sure that these lines LM is parallel to PN. Number 1, for lines to be parallel, a line drawn, a perpendicular drawn from one line to go and touch the other line, it will strike it at 90 degrees. It has to strike that other line at 90 degrees. So we'll go back to the diagram and see, does that happen? We have line L, M, and PN, which are the lines in question, which we have to prove they are parallel. Isn't it? So let's go to the lines. This is line LM. When I have a right angle here, it shows that MN acts as a perpendicular. MN acts as a perpendicular. And that perpendicular goes to strike line PN at what angle? You can see it is 90 degrees. That is only one end, isn't it? So if you prove it on one end, it is already a true proof, but we have still to get the other angles. Let's move to these other points. We have LP, which is acting as a perpendicular because it is line LP is meeting line LM at 90 degrees. And it is also meeting line PN at what degrees? At 90 degrees. That is a sure proof that the two lines are parallel. So to get to the proof, we say we now have LP and MN will act as a perpendicular. So for lines to be parallel, a perpendicular drawn from one line should meet the other line at 90 degrees. So let's go to our diagram and see, does that happen? LP and MN are acting as our perpendiculars, isn't it? So perpendicular, when you say perpendicular LP, it is rising from which line? Line LM. And it goes to meet line PN at 90 degrees. So you simply say perpendiculars they have acquired a name, perpendiculars. Perpendicular LP and MN from line LM meets line PN. They meet line PN, you can see, at line PN at 90 degrees. Therefore, line LM is parallel to line PN. That is a direct proof that the two lines are parallel, because the two perpendiculars drawn from one line go to meet the other line at 90 degrees. That is just one of the methods. The other method, there is an angle given there, x. That angle could lead us to having another alternative solution of proving that the lines are parallel. So we have an alternative solution. We have an alternative. So in the alternative solution which we have, I'll have to draw a diagram that will help us to solve that question. So that is our diagram, and we had an angle here, x, which is going to help us in the proof. So if we have a diagram, in the first one we used the perpendiculars. So you realize two parallel lines. If we have two parallel lines, if we have a vertex drawn from one line to go and cut the other line, it will form a pair of alternate angles which should be equal. So let's look at our diagram and see how that will come about. We have line LM and PN. MP is a line right from line LM going to cut line PN at point P. So if the lines are parallel, isn't it? So if the lines are parallel, the value of this angle, I can just use A degrees will be equal to B degrees. So I say parallel lines form a pair of alternate angles which are equal. In our question, the angles in questions, we are talking of if x will help us to get the value of A and B, then we find they are equal, then the lines are parallel. If LM is parallel to PN, angle A will be equal to angle B. So having that, I have to calculate the value of angle A and also the value of angle B. And then I compare their values. If their values are equal, the lines will be parallel. So let's go to the length of finding the value of angle A. So we go back to the diagram. That is a straight line. This is angle A. It is arising from an isosceles. So from the isosceles triangle, we find in an isosceles triangle, we have a pair in the isosceles triangle. The two values should be equal. So if we have OPN as A, we shall have ONP as A degrees. So there is another angle in the isosceles triangle which we've not got, but X will help us to get that angle. That angle is PON. And given that X added to that angle gives 180, therefore the value of PON will be 180 minus X degrees. So we'll go back to a concept that the three angles in a triangle add up to 180 degrees. So therefore A plus A plus 180 minus X should give us 180 degrees because there are three angles in a triangle. So from that equation, we shall get the value of X. So we continue. A plus A, 2, we'll get 2A plus 180 2A plus 180 minus X is equal to 180. So since I'm only interested in X, I'm only interested to get the value of A. I'm interested in to get the value of A. So I'll leave it on the left hand side of the equation. So I'll have, the other ones will go the other side. So I'll have 2A. When this one goes, the other side becomes a negative, it's a positive. So we'll have 2A is equal to 180. Take it the other side, becomes minus 180. This is a negative. Take it the other side of the equation, it becomes a positive. So moving down, we shall have 2A is equal to 180 minus 180, you get 0. Then you remain with x. So from that, to get the value of a, I'll divide 2 on both sides. So a will be equal to x divided by 2. That will be the value of a. I've already got the value of a. My next step will be getting the value of b to ascertain whether it is equal to a, because the series of alternate angles I was talking of were a and b. So I'll go back to that diagram. Given that PON is 180 minus x, it is directly opposite to LOM. So directly opposite angles are equal. So this angle will be what? 180 minus x. And since this one is also isosceles, this value of angle MLO will be B degrees. B degrees. So right from what I did here, it will also be therefore, from the diagram, B plus B. B plus B plus 180 minus x. It will give us 180 degrees, because those are 3 angles in a triangle. So let's move ahead with the equation. B plus B, 2B plus 180 minus x should give us 180 degrees. So I'm interested in B. So B will remain on the left-hand side of the equation. So we move ahead by saying 2B is equal to, you take 180 the other side, it becomes 180 minus 180 plus, x now becomes plus. So 180 minus 180 is 0. Therefore, 2b is equal to x. Therefore, b is equal to x divided by 2. So you find that the value of a is equal to b. So you write a is equal to x divided by 2 degrees, and b is equal to x divided by 2. Therefore, a is equal to b, and therefore line LM is parallel to line PN. So that is a proof that the two lines are parallel, because we found out that the pair of alternate angles they are forming, it will always happen when two lines are parallel. A is equal to B, and the two angles are alternate and equal, and we have proved the value is x divided by 2. So that is the alternative solution, which we worked using the value of angle x. We've come to the end of the lesson today. So I'll give you an assignment from the learner's book. The assignment. Thank you. That's what we'll do for the assignment. See you in the next lesson.